Bismillahirrahmanirrahim. I am Dr. Syed Azhar. In this lecture of linear algebra, we will discuss linear combination of vectors. The definition is, let V be a vector space. A vector U is called a linear combination of these vectors U1, U2 up to Um if there exist scalars x1, x2 up to xm such that x1 u1 plus x2 u2 plus x3 u3 up to xm um equals u. This equation is basically the relation between these vectors u1, u2 up to um and this vector u. For linear combination, basically we have to solve this equation and we have to find these scalars x1, x2, x3 up to xm. If such scalars exist which satisfy this equation, then we will call this u as a linear combination of u1, u2, u3 up to um. For example, in this figure A, here we have two vectors u1 which is 3i plus j and u2 which is I plus 3j. If we add these two vectors by using head to tail rule, we get its resultant vector 4i plus 4j. Since this r is a resultant vector of u1 and this vector u2, in linear algebra we say that this vector r is a linear combination of u1 and u2. In this definition, such type of vectors are represented by u, and such type of u1, u2 vectors are represented by u1, u2 up to um. In this figure A, this r is the resultant of these two, and there may be so many vectors which we can write in terms of u1 and u2, and all those vectors are known as linear combinations of u1 and u2. For example, 2u1 plus 3u2, this gives us 2u1 is basically 6, 2 plus 3u2 is basically 3, 9, and this gives us 9, 11. So this one is also a linear combination of these two vectors. Now example, let u1 and u2 are given and we have to check this given vector u whether this vector is a linear combination of u1 and u2 or not. And question is, can u be expressed as a linear combination of u1 and u2? So according to this definition, we have some scalar x1 into u1 plus some scalar x2 into u2 equals this vector u, because we have to check this vector, so that's why we wrote u on the right side. Put the values of u1, u2 and u, we get x1 into u1 vector plus x2 into u2 vector equals u vector on the right side. Now multiply x1 with 1, 2, minus 5 and x2 with 2, 5, 6 and then add these two vectors. We will get x1 plus 2x2, 2x1 plus 5x2 minus 5x1 plus 6x2. From this matrix we can write x1 plus 2x2 is equal to 1, 2x1 plus 5x2 is equal to 4, and minus 5x1 plus 6x2 is equal to 27 gives us the third equation of this system. Clearly this system is a linear and non-homogeneous. To solve this system, we have to write this system in its augmented form. So its augmented matrix is 1, 2, minus 5. This is basically representing the coefficients of x1, the second column representing coefficients of x2, 2, 5, 6, and 1, 4, 7 is representing the entries on the right side of the system. To solve this system means to find x1 and x2, we have to transform this matrix into echelon form. Now this first entry, our first row, is known as a pivot entry. So according to echelon, entries below this pivot entry must be zeros, so we have to eliminate 2 from the second row and minus 5 from the third row. To eliminate this 2, we will subtract 2 times of first row from second row, and to eliminate minus 5, we will add 5 times of first row in the third row. So these are our desired row operations. Clearly, the first row will remain same, and 2 times of 1 gives us 2, and subtract that 2 from this 2, we will get 2 minus 2 equals 0. 2 times of 2 gives us 4, and subtract that 4 from this 5, we will get 5 minus 4 equals 1. 2 times of 1 gives us 2, and subtract that 2 from 4, we will get 4 minus 2 equals 2. Similarly, according to second operation, we have to add 5 times of first row and third row. So 5 times of 1 gives us 5, and add that 5 with this minus 5, we will get minus 5 plus 5 equals 0. Now 5 times of this 2 gives us 10, and add that 10 with 6, we will get 10 plus 6 equals 16. 5 times of 1 gives us 5, and add that 5 with 27, we will get 27 plus 5 equals 32. Clearly, these two are the pivot entries. So according to echelon form, we have to eliminate this 16, as this 16 lies below this pivot entry. To eliminate this 16, we have to utilize the second row, and for that purpose we will subtract 16 times of second row from third row. So this one is our desired row operation, or 3 minus 16 times R2. The first and second row will remain same. 16 times of 0 gives us 0, and subtract that 0 from this 0, we will get 0. 16 times of 1 gives us 16, and subtract that 16 from this 16, we will get 16 minus 16 equals 0. 16 times of 2 gives us 32, and subtract that 32 from this 32, we will get 32 minus 32 equals 0. Now look at this matrix. Clearly, these are the only 2 pivot entries, and these 2 pivot entries are associated with first column and second column. Since first column is representing the coefficients of x1 and second column is representing the coefficients of x2, so x1 and x2 both are basic variables. Now from second row we get x2 equals 2, that is x2 equals x2, and from first row x1 plus 2x2 is equal to 1. Put this value of x2 in this equation, we will get x1 is equal to minus 3. As we obtained the values of scalar, so we can write u is a linear combination of u1 and u2, that is u is equal to minus 3 times u1 plus 2 times u2. And you can verify your answer by putting the vectors on the left and right. This one is another example related to linear combination topic. Here u1, u2, u3 and u vectors are given. The statement is, can u be expressed as a linear combination of u1, u2 and u3? So just like previous example, let us consider some scalar x1 into u1 plus some scalar x2 into u2 plus some scalar x3 into u3 equals u. Now put all these given vectors in this equation, and then multiply x1 with 1, 2, 3, x2 with 1, 3, 5, x3 with 1, 5, 9, and add all these vectors on the left side. You will get x1 plus x2 plus x3, 2x1 plus 3x2 plus 5x3, 3x1 plus 5x2 plus 9x3 equals 278. From this matrix system, we can get x1 plus x2 plus x3 equals 2. This will be the first equation. Now 2x1 plus 3x2 plus 5x3 is equal to 7 will be the second equation of our system. 3x1 plus 5x2 plus 9x3 is equal to s. This will be the third equation of this system. Clearly, this system is a linear system and also a homogeneous system, and we have to solve this system for x1, x2 and x3. So its associated augmented matrix is 1 1 1 2 2 3 5 7 3 5 9 8. Clearly, this one is a pivot entry, so we have to eliminate 2 and 3. To eliminate 2, we have to use R2 minus 2R1 as a row operation, and to eliminate 3, we have to use R3 minus 3 times R1. So the first row will remain same. 2 times of this one gives us 2, and subtract that 2 from 2, we will get 0. 2 times of 1 gives us 2, and subtract that 2 from 3, we will get 1. 2 times of 1 gives us 2, and subtract that 2 from 5, we will get 3. 2 times of 2 gives us 4, and subtract that 4 from 7, we will get 3. Similarly, in the third row, 3 times of 1 gives us 3, and subtract that 3 from 3, we will get 0. 3 times of 1 gives us 3, and subtract that 3 from 5, we will get 2. 3 times of 1 gives us 3, and subtract that 3 from 9, we will get 6. 3 times of 2 gives us 6, and subtract that 6 from 8, we will get 2. Here, these two are the pivot entries. Now we have to eliminate this one. So for this purpose, we use this row operation, R3 minus 2 times, this one is R2. R3 minus 2 times R2, this one is our desired third operation. So the first two rows will remain same. Now, 2 times of 0 gives us 0, and add or subtract with 0 will give us 0. 2 times of 1 gives us 2, and subtract that 2 from 2, we will get 0. 2 times of 3 gives us 6, and subtract that 6 from this 6, we will get 0. 2 times of 3 gives us 6, and subtract that 6 from 2, we will get minus 4. Now look at this system. The rank of this whole matrix is 3, because there are 3 non-zero rows. And look at this coefficient matrix. Its rank is only 2, because we have 2 non-zero rows. The third row is 0, so the rank of coefficient matrix is 2. And clear 3 is greater than 2, that is, rank of augmented matrix is greater than rank of coefficient matrix. So the system is inconsistent. When the system becomes inconsistent, then we cannot write U as a linear combination of the given vectors. Now, this one is the last example of today's topic, linear combination. Let we have U1, U2 and U3. Can U3 be expressed as a linear combination of these vectors? So in the solution, let x1 u1 plus x2 u2 plus x3 u3 is equal to u3. So now put the values of u1, u2 and u3 and add them, you will get this system. To get the solution, we have to transform this matrix into its augmented form. So this one is its augmented form. To get the solution, similarly, we have to eliminate 2 and 3 from these positions to get the desired matrix. So these are our desired operation. Later on, we will use this operation, and then we get 1 1 1 1 0 1 3 3 0 0 0 0. Now look at this matrix. The rank of augmented matrix and the rank of coefficient matrix both are same. So we say that this system is a consistent system, and it means that we can find its solution. Since x1 and x2 are the basic variables while x3 is a free variable, so let x3 is equal to x3. From the second row, we obtained x2 plus 3x3 is equal to 3. We get x2 is equal to minus 3x3 plus 3. From first row, we get x1 plus x2 plus x3 is equal to 1. Put these values in this equation, we will get x1 is equal to 2x3 minus 2. Since x3 is a free variable, so we can choose any value for x3. So let us consider x3 as 1. Then what will be the values of x2 and x3? Put that one in this equation. x2 is equal to minus 3 into 1 plus 3 will give you 0. Similarly, here put x3 is equal to 1, we will get 2 minus 2 equals 0. Since we obtained the values of x1, x2 and x3. So this shows that u3 is a linear combination of u1, u2 and u3, and that linear combination is this one: 0 times u1 plus 0 times u2 plus 1 times u3 is equal to 3, because this one is x1, this one is x2, and the value of x3 is 1. Similarly, you can express u2 in the linear combination of these three vectors, just like 0 times u1 plus 1 times u2 plus 0 times u3 is equal to u3. Similarly, you can express u1 also. So u1 can be written as 1 times u1 plus 0 times u2 plus 0 times u3 is equal to, this one is u2 and this one is u1. So this is the end of today's lecture. Hope so you will enjoy it. Feel free and ask questions. Thank you.